Hello everyone. Today I am going to deal with one of the very important topics. Wherever the numerical ability part is included in a competitive examination, you cannot escape this topic of ratio and proportion. Now, these are very common questions when we deal with the mathematical ability or numerical ability questions, and most of us apply longer methods to deal with these questions. So today I am going to tell you some of the shortcuts which can be applied in some particular problems of ratio and proportion. So the first type of problem is when you have to divide a larger number into two parts whose ratio is given. Now say I am taking an example of say 702. Now we have a larger number 702 and we have to divide this 702 into two parts. The ratio of the two parts is 4:9. Now when you have to divide this number into 4:9, then normally what we do is we assume the numbers as 4x and 9x, and then we carry on with the longer method. Now the first part which we have to find out is just to have this first ratio divided by the sum of ratios 13 and multiply by the overall number 702. Normally in competitive examinations, this number is normally divisible by the sum of the two ratios so that you arrive at the right answer in lesser time. So here also this 702 will be divisible by 13. Now when we divide 702 by 13, we get 13 5s are 65, 52, 13 4s are 52. So 54. And just we have to multiply by 4. Now again multiplication by 4 involves yet another method which I told you in previous tricks. Like multiplication by 4 is not actually a multiplication problem. It is doubling the number twice. So when we have to double 54, then 54, 108, and 108 again double 216. So answer is 216. So the first part is 216. Now second part obviously is found out by subtracting the number and the first part 216. So this number will come out to be 486. So the two parts are 216 and 486. So these are one type of questions where you are given a larger number and you have to divide it into two parts whose ratio is given. Now similar questions can come in geometry portion also, where you are given that the ratio of the three angles of a triangle, in case of a triangle, the ratio of the three angles is 2:3:4, and we have to find the three angles. Now again the same rule applies here also. First angle is 2, this is 2 first ratio. Now divided by the sum of ratios 4, 5, 6, 7, 8, 9, and the total is 180 degree obviously. So we have to divide 180 into 3 parts. Now this is 20 into 40 degree. Second part, second ratio is 3, so 20 into 3, 60 degree. And the third, 40 plus 60, 100, so 180 minus 100, 80 degree. So this is how we do the calculations in competitive exams. We don't have to use the traditional method which is taught at class 6, class 7 level when the children are studying the ratio topic for the first time. Now coming on to another important concept of proportion. When two ratios are equal, then the four numbers involved are said to be in proportion. Like we have an example of 5, 6, 20 and 24. Now this 5:6 is obviously in lowest form, we cannot simplify it further, but 20:24 can be simplified by cancelling the common factor of 4. So 5 ratio 6. So you see the ratio of the first two and the ratio of the last two is same. So we call them in proportion. So these four numbers are in proportion. Now dealing with proportion, how do you find whether four given numbers are in proportion or not? This is one method which I told you. You have to take the ratio of first two and the ratio of last two. If the two ratios are equal, then the four numbers are in proportion. But in competitive exams, when you have to check whether these numbers are in proportion, then you just find the product of extremes, that is the first number and the fourth number, 5 into 24, 120, and the product of remaining two numbers, those are called means, product of means. Now means are 6 and 20, so 6 and 20, again the product is 120. So if these two products are equal, then we call the four numbers are in proportion. So this is one of the shortcuts where you have to find whether the four numbers are in proportion or not. Now this concept of product of extremes is equal to product of means can be used to find fourth number when we are being given four numbers and one number is a variable. Now suppose I take the same example of 5, 6, 20 and 24. Now suppose the question is you have to find this x. You are given that these four numbers are in proportion and you have to find x. This x can come in place of any of the four numbers. So you can find x directly without implementing any method in this. Just do the product of extremes because both the extremes are known, and just divide it by the one of the means which is given. So the answer will automatically come out to be 20. Similarly, if x lies at some other place, suppose we have x at the fourth place, 5, 6, 20 and x. Now both the means are known, multiply both the means and divide by the extreme which is known. Again the answer will come out to be 24. So the two known quantities, if the two extremes are known, then multiply the extremes and divide by one of the means. If the two means are known, then multiply the means and divide by one of the extremes. So you can find the fourth proportion if three of the terms are given to you. This is again the shortcut for finding one of the means or one of the extremes in a given proportion. Now come to another important topic concerning this ratios. Now I have the problems of inverse and direct proportion. Now for direct proportion, I'll illustrate one example. This is very important from examinations point of view, and for inverse proportion also. When I tell you that this is the inverse proportion question, you will realize that yes, this is the question which is unavoidable in competitive exams. Every time you face a numerical ability test, you confront that question. For direct proportion, let me take a very simple example. Suppose 5 pence cost you rupees 11 and you have to find the cost of say 17 pence. Now this is a direct proportion. Direct inverse variation questions are slightly different from direct proportion. Here as the quantity increases, the cost also increases. So it is direct. See, the answer for this is obtained by just going in the reverse order. Like you have the order 5, 11 and 17. Your answer is 17 into 11 upon 5. See, I have gone in the reverse manner. 17 into 11 is divided by 5. So you get the answer here. Just cancel this 2.2 times 17 into 2.2 and you get the product 17 into 22. 7 to the 14, 4, 1, 15, 16, 17, 7, 1, 3, 374, 37.4 is your answer. So see, when you have a direct proportion question, then you go by reverse order. 17 into 11 upon 5 is the answer. Now coming on to inverse proportion. Now obviously when direct proportion gives you the answer in reverse order, then inverse proportion will give you the same answer in straight order. Now I'll take one example for this. Say this is a very common question for competitive exams. Suppose 12 men can do a piece of work. Now again, this piece of work, time and work questions are very important. Suppose 12 men are there and they can do a piece of work in 30 days. So now if the men are reduced to 8, how many days will it take for 8 men to complete the same work? Now see, it is a inverse proportion question. Why? Because if the number of persons decreases, then obviously they'll take longer number of days to complete the task. So now the answer is in the straightforward manner, 12 into 30 upon 8. Multiply the first two and divide by third. So 2s are 3, 15, answer is 45 days. That's all. So if you know the concept, if you know the shortcuts for solving these types of problems, I think you will take 1/4 of the total time which other people are taking when they are utilizing traditional methods to solve these type of questions. So students, aspirants, please practice all these methods of ratio and proportion. It takes just 1 hour time to master these skills, and mental maths is really a fun. It produces amazing results. Keep sharing and keep subscribing if you like the video.